right. Hello, everybody. Thank you for joining. We're back once again with InterSystems Developer Community Winners Meetup for our latest programming contest. I'm Dean Andrews, Head of Developer Relations at InterSystems. We're all very excited to be here once again. We did something a little bit different this time around. We focused our full stack application contest on climate change, and we're very excited about the results. We normally are kind of focused on a specific technology, but this time we wanted to focus in on a world challenge, and so this was a great first try, and we had some great results. We had an expert in the field speak at the beginning when we first launched the contest. I don't know if you want to say any comments about the results that we've seen here this time.
Thank you, Dean. First of all, I was surprised how quickly the ideas come to solutions. And because, as you know, I'm familiar now more and more about InterSystems solutions, and overall, I could say it's a perfectly utilization of methods, of solutions, of tools what InterSystems already built. And I think it's very creative how developers made it in very short time.
Indeed, totally agree there. So without further ado, let me go down and show the list of winners. This time, as we often do, we had both the expert category and community nomination, and it actually lined up as a direct match in terms of the places. So we just need to do one set of demos here. We also did have our technical bonus category. So we did award some other applications that were submitted as well. So just a great response overall. Thank you all for participating and continuing your work in innovation on our platform. It's very, very exciting, and we love your support. We can just go ahead and dive right into the demos. I do want to make just a quick programming announcement that we do want to keep the demos to 5 minutes if we possibly can. And so that will leave us some time for question and answers after each demo. So let's go ahead and start with Yuri for third place for the carbon footprint counter, please. Thank you.
Thank you, guys. My name is Yuri Gomes. I'm from Brazil, and I system architect. I will share my screen. You can see?
Yes.
Okay. My app, Carbon Footprint Counter, is app to calculate gas emissions, greenhouse gas emissions into enterprise based on GAD protocol. This GAD protocol has a Excel document with the emission factors, and you can calculate stationary, mobile, electricity emissions. So I created IRIS app to do the same thing, but in a database with governance and management. So when you install the app using ZPM or Docker Compose, you get a web app, and this web app, you can set stationary, mobile, transportation, and electricity emissions and calculates the total emissions here. So when I go to a stationary emission, I set the facility within a year, a list of fuels here, natural gas amounts, and I get CO2, CH4, N2O emissions here. And I save, we have total emissions here. And you can do here for cars in the company. Gasoline. You can get the emissions here. So you set your transportations as airplane travels and electricity you buy, and you have total emissions here. With the total emissions calculated, you can take actions to neutralize these emissions. The app was built using IRIS with Objective-C to do the REST services, and use it, and I use an Angular to the web application here. I did some unity tests, and all the app is running fine. Okay, so this is my app.
That's excellent. What did you, I'm curious, Yuri, what did you think about the contest being focused on climate change? Did that change the way you thought at all about, developing an app for the contest?
I love it, this talk, because climate change is running in all the world. In Brazil, and the climate is crazy now, and the rest of the world too. So I love it to contribute with my app.
Any questions or comments from the team? All right. Then let's move on to thank you very much, Yuri. Very exciting. Thank you. So let's now we're going to go to Sean, the first place winner with the Kozo app.
Okay, hopefully you can see my screen. Yep. Okay.
Yes.
So let me explain. So Kozo is a type of Japanese paper. It's made from the inner bark of the mulberry tree. It's developed using a process called washi. And the nice thing about Kozo paper is the mulberry branches are chopped off and the trees are not chopped down. There's no chemicals used. So it's a good example of paper that's produced in an environmentally friendly and sustainable way. Kozo Pages is also the name of the application. In fact, the slideshow that you're looking at right now is built using Kozo Pages. The purpose for Kozo Pages is to write technical documents, make letters, static pages, application pages, and also dashboard views. So it's a multi-purpose tool. It's a hybrid solution, so it does combine both the server and the client. So it's combining the power of server actions, so SQL, object script, also Python, with best of breed awesome JavaScript libraries for doing your front end presentation. So that includes Markdown, Handlebars, Mermaid, Chart.js, D3, which is very versatile, obviously using SVG. But essentially, you can integrate any technology. I've already mentioned the server actions. Python is something that I'm working on at the moment, and that's using the embedded object script Python. And one of the things that the server actions do is to make the pages dynamic. So it kind of brings, whether you're doing a dashboard or you're doing a document, it brings that page alive. So in this example, we're setting a value on the server and we're embedding it using handlebar logic. And you can see this is the output that we're getting. So if we have a look at some examples, so here's the kitchen sink demo. So this is showing us using Markdown with Markdown syntax, where we can embed images. We're using code fences for diagrams and charts. We're able to interrupt the page and include forms driven by the data in the page, and that's going to dynamically update the rest of the document. We've got line charts, user journeys, pie charts, Gantts, bubble charts. So the possibilities are endless. So basically, if there's a JavaScript library that can do something, the idea of Cozo Pages is being able to embed it as easily as possible. And here's an example of just embedding some table data. Here's a quick example. Oh, let me just show you the edit mode for this, just to show that this is actually an editable component. So you can see, actually you couldn't see it then, but we're editing the top of the page there, and it's dynamically changing as we're doing that. The nice thing about this approach is it's not WYSIWYG, but you get this live edit view of what you're doing. Here's an example of some code fences. So we've got some Mermaid in here. So that's just a Mermaid syntax for driving these diagrams. So all you have to do is embed them in these fences and then go to the documentation for the library that you're using. In this example, we can see we're actually ping-ponging backwards and forwards from the server to the client, to the server to the client, which is quite interesting because it allows us to have this page data object, which we can move about and update and change as the document itself is changing. So we've just got a counter here going at 1, 2, 3. We can also fetch like an object, for instance, here, and then embed that in here. If I actually go and look at that, that page we're editing, you can see the code fences here where we're actually embedding data get embedded into a method. So depending on the code fence, the cool idea of the code fence determines what's being called here. Here we've just got a simple letter, just to prove that these things are pages themselves. So we can generate a PDF document from this. So one of the drivers behind this is to auto-generate technical documentation. So if you think about if you're producing technical documentation for things such as an integration solution, you might have lots of config, IP addresses, ports, lookup tables, all those sorts of things, which normally you'd have to cut and paste them across into your documents. With this solution, you have them dynamically injected. So as you change your software and you book your software back in, you're just regenerating the document rather than having to maintain the document as well. And so one of the interesting drivers behind how I came about the solution was thinking about data scientists. So data scientist obviously knows data. They're going to be programmers, I assume, obviously being able to do SQL and be able to do certain amounts of dynamic coding, but not necessarily bring that together into applications or dynamic documents which require lots of glue code. So this concept of a low code solution where somebody can come along and build out these solutions. So the challenge with the climate data was to see what I could do in the time given to go off and grab some data. So I went off and ended up grabbing the Berkeley Earth data, and we can see what we've got embedded here is all dynamically driven. So the SQL here is looking at the spread of years, and here the spread of logs for each year. And I was trying to think about how I could represent that in the graphs in a way that would demonstrate that there is some change, some action going on in the climate. So I essentially grouped the months together into centuries, stacked them together, got the average, and then put those on top of each other. And the result was quite startling, actually. I wasn't expecting to be shocked by doing this, but actually it's given me quite an insight into into the climate data. And I produced this second part, which is purely driven by these two inputs. And so I can, if you look here, we've got the 21st century in red and the 19th century in green. And if you look around all the cities, you're going to see time and time again that there's a considerable gap between these locations. So I don't know if I just pick another one. So it's going to update. If I pick Boston, let's say. And again, you can
Wow.
see there's these significant changes going on, and it's incredible really to just see how consistently there is a gap at the top. And this data is doesn't include the last 10 years. So that is COSO pages. Pretty. I'm not sure if I stuck to my 5 minutes, but that's the essence of it.
Very exciting. It's and I think a very clever approach because at least from my perspective, it's almost like you're empowering data science to both show and perhaps educate on climate change, as well as creating a powerful tool that can be used for many purposes. Quite cool. Thank you very much. Any comments from the team?
Maybe I will give us some comments, Dean.
Yes.
Thank you. So, Sean, I want to say that one of the biggest challenge in the climate change question, and overall, it's insights for people who is not familiar with the concepts, what is really happening, and who have concerns, doubts, and they don't trust to resources. They don't know what the kind of resources is trustful. And actually, you choose not only the biggest set of data, but you also choose one of the most correct set of data. And it started in London, and it's a city who was one of the most advancing statistics in the history. And then other countries and start to learn from it. And the temperature is the most like a black and white. You just every day you just have these figures, and you just you don't have emotions about it. And now after so many years of collecting of this type data points, now we staying on their shoulders, we could easily show the insight. That's a power of data, and that's a power of creative way of how to use data. And that was surprised me when I start to explore that we have simultaneously using the technology itself and building the tools. And I agree with Dean here that it's a tools for everyone. And at the same time, it's a very proactive and insightful way to showing the data. And if other data scientists and the students and other people who interesting more and more, they will start to use data and play with data by themselves. That's most powerful, because they will see by themselves. It's kind of doing investigation, you know, and that's the tool impressed me, and I want to say thank you. And it's not mean it's just comparing with other solutions why I choose this. I give a vote, my vote, because it's impact to the developers and also impact to the climate change. It's very unique combination.
Thank you.
Agreed. Yeah.
I wanna comment this project too. So Sean, yes, thank you so much for contributing this. And as Einar and Dean mentioned, that it is a great research on the climate change, and also agree. And also, I just love it, because for me it could be, maybe it will be a new tool, day-to-day tool for doing any researchers when I need to present some information or some data that is in IRIS. So previously I was very much envious to Python guys that they had Jupyter notebook. Now we have Cosa notebook for Cosa pages, so that all, even for the first release, has so many features that will help us to deliver really very well done researches, like with a very well thought representational layer. So thank you, Sean, for giving this to the community, and I agree with others that this is a great work. Thank you.
Thank you. Thank you.
All right. Great job. Let's jump to Mohammed. Sorry, we skipped you in the order, Mohammed, but go ahead and demonstrate your IRIS climate change app, please.
Hi all, this is Mohammed Waseem. I'm from Jeddah, Saudi Arabia. So can you see my screen, please?
Yes.
Okay, so this is a demo of my application. This is IRIS climate change. Main thing is here is the data set. So data set I took from this site, the Food and Agriculture Organization, climate change. So this is a data set. You can download from here. This is the territories, countries, and here we can download the data from here. And these are this is the license details, so we can use for demo purposes. So I'm using Python Flask web framework, and by using embedded Python. Main libraries I'm using Pandas, Python data analysis library, and Plotly. This is for the graphics. And this library I'm using to display the graph on the website. This is JavaScript library. And there are some graphics. This is a map animation. There are some bar graphs, a line chart, and radar charts. Let me go to the source. So here, this is the Dockerized application, and here in the data I have these two files. This is one is representing the history of last 60 years of data, and then we have here all the countries and territories. So initially at the start of the application, I am importing this data to the IRIS. For this, I'm using this object script. This is the utility class under DC climate change directory. So this is a function is called first time when we are initializing the application. So it's just guessing the data types based on the first and second row. Then it's just assigning the table name, and then it's creating the table and the columns. And after that, I'm using the load data functionality to load the data from this CSV file to this table. The same I'm using here for the, this is for the countries and territories, and this is for all the data. So once the data is imported in IRIS, then I'm using the Python code to represent the data on the website. This is a Flask application. So this is our main code. So this is a pandas library for data analysis and for some data sciences. And this is a plotty, this is for the representing the graphics. So the first of all, and just let me run the application. So already Docker is already initialized. So this is a localhost 4040. So this is the interface of the application. So mainly is a data set is just showing the details. This is the same site. We can call it from here to get the details of data set, licensing information. And this is the two tables. Even from here, we can get it. These are the countries and territories. Now this is reading from the IRIS. It's already imported. So this is all the data. We have around 321 countries and territories. And then we have the, this is the data set, the world data. It's representing here the data. So let me just, so basically it's displaying all the data here by the years. We can see the data here, either from the IRIS SQL. So this is the table. So these are the two tables. So this is the data is executing. So this is the data of for last 60 years. So representing all the years in columns. And then its data is representing as a centigrade. This is a unit. So what is the application is getting the data, and let me go to the application again. So these are the different graphics I'm representing here. First of all is the climate change. It's saying the global service. This is the map animation. It's reading the data here, and it's showing all the years here, and we can just scroll and we can reach up till all the years we have. So it's displaying here, this is a climate change. We can see all the details by just hovering the mouse. So this is displayed at the how that climate is changing, especially for the last decade. This is a good representation of the data here with the map. And then we have this, the top 10 countries suffering the temperature last 10 years. So I'm representing this by a bar chart. So it will just read all the data. It will display the last 10 years, all the temperature of the countries. And same it's here, this is suffering the most, and this is the least temperature change for the last, for the 10 countries. And here is showing the trend between the years according to the world. So this is, I'm using the radar chart. It's also from 1961 till 2021 is showing all the data change based on the world, and is categorized by the annexed countries and non-annexed countries. And at the end, there is a radar chart. This is also displaying all the data of global warming. So same way like the map, we can also view the data based on the years, and we can also replace just to view the data like this. So just let me show you the detailed code of this map animation. So here we are using this. This is a function basically we are calling to display the data here from the application. And let me go to here. So in the here so this is basically function is called when we are calling that site, and it's just getting the data. Yes, from there's another function to read the data from that from IRIS, and then making the copy of the data, and then it's using the this basically PX is a library here. This one Plotty Express. So display this data in the graphics. So just this there is some filters are here, and then it's just updating the layout, and then at the end it's this is a main trick here. It's just using the JSON dump function to just convert all this data to the JSON, and then it's passing to the website. And then that graphic library will just convert this data and display on the website. So this was the tricky part here, because getting the data was easier, but to display on the website was a trickier part. So this is the main trick here. So same thing happened with other as well. So it's just getting the data frames or all the functions. For example, this is the trend also. It's just reading all the months, and then just based on this filters, it's reading the data and passing to the website. So that's it. So that's how it's just representing the data to the from IRIS to this Flask website.
That's awesome. Great data visualization there. Let me ask you, Mohammed, how did you find this contest with its focus on climate change? Was that interesting to you, or how did you think about it?
Yeah, it was a new thing to me, and because as already mentioned before, that this is a new way to do it. So the challenging part was to just get the data set and how to represent there. So yeah, I really found it very interesting, and I learned a lot from it.
Thank you. Any comments from the team?
I have question.
Yes,
maybe not comment for Mohammed. So what was the most insightful things what you get from your data and your when you visualize it, what you get from these insights?
Yeah, what I got that the climate is changing for the especially last the decade, and this is basically main of the industrial countries where we have more industries. So world need some greenery and some sort of thing, so we can just control this temperature.
Mm-hmm. Thank you.
Okay, welcome.
Yes, I want to comment this too. So, Muhammad, thank you for yet another great example of usage InterSystems IRIS and some other technology. This time is Python, some Flask. So it's a great contribution how easy and elegant people can visualize data from IRIS in web applications using Flask and Python libraries and other people. Thank you for that. And it's very insightful. You introduced several different tools to represent the data. These rows, these trends, and map. So it's very obvious. Expressive.
Thank you, Mr. Avgani. Thank you.
Maybe any other comments from people in the call?
We will listen any other solutions, or I because I have a general question for every participant.
Go ahead.
Because I first time to participate in this type of contest. My question is for everyone: why you decide to join this contest? What was your motivation? And the first and second, is it your daily work of programming, or it's your hobby, or it's and what is the connection with your current things? What you're doing in this contest?
Yeah, should I start?
Yeah,
Sure.
thank you. Yeah.
Actually, I'm participating since last few months. So almost in every contest I participated. So every time I find new things, and it's challenging for me. And for us, we are already moving to the track here. So InterSystem, I'm just using the tools of InterSystems. So basically, I'm a developer. I have, so this is that's why I'm just participating to learn more things. And this is a very great way to learn exactly, especially whenever we find a new things. So this was a really new things for me. And as I told that I learned a lot from it.
Thank you.
My motivation is take action, because we see climate change, and we need to take action with the data we collected and show. So my app is a good example how to know the impacts in the climate change, and with number you can plan your action in the enterprise, in the companies.
Thank you.
Thank you, Yuri.
Any thoughts, Sean?
Yes, so so for me, I think I get a little frustrated with the way mainstream media present climate change, because I see the effects that presentation has on people's mindsets. And so I think there is still a large number of people that are looking at the sort of extremism, the doomsday predictions, and saying, well, you know, I don't think it's as bad as what they're really saying. And, you know, maybe it's being caused by the Earth's spin, and it's the ice age, you know, sort of going in cycles, etc. And maybe those things have some contributing factor, but there's something undeniable about the fact that there is change happening. And what we really need to see, I think, is evidence, clear evidence, without any manipulation of data or charts in a way to, you know, make it look extreme. And for me, there was something very different about working with the data in terms of conceptualizing what that change is. It's kind of, you know, I had 2 dimensions before, and now I've got 3 dimensions in my brain as to this problem. And it's given me a greater feeling of urgency of what we need to do. And, you know, maybe it's not the doomsday issue, but it's definitely going to cause a lot of problems around the world. You know, there's going to be populations that are going to have these issues, not in 100 years, but in the next decade. And so, you know, we have to think about what we can do for that. And just working with those temperature datas, as simple as it was, has kind of turned something in my brain. I feel as if we could take that data and the way it was constructed there and generate a static site, you know, that works in milliseconds rather than, you know, having to run these long running queries, and make it accessible. I think that could be something, you know, I feel like that's something I need to do now after doing this exercise. So yeah, it's definitely, I think people need to work with the data, you know, in whatever form, to get their own opinion.
Thank you so much. I will say I found this and all of your work inspiring. So thank you. And it's, to me, it's just a wonderful example of applying engineering and software development to real problems to try to help. So it's amazing stuff. I'm very glad that we did this contest in this way. So thank you all very, very much. We are all set for this winners meetup. Evgeny, did you
Just
have?
a moment.
Yeah.
I still, Raj, maybe you want to say something? Yeah. No. I actually just want to comment that this is the first contest where we took a global challenge, and maybe we can discuss a little bit what if we continue this approach and what could be the next global challenge. We will ask community to research, to work with maybe any instant ideas. So we started to discuss it before we launched the session. So, and Einar, so you want to introduce something? Please go ahead.
Yes.
Yeah, thank you. So first of all, I think the climate change itself, it's a huge problem, and it's a lot of dimensions of this problem. And as Sean also mentioned, what kind of problems it's in the media, yeah. But what I could say, to understand climate change, very quickly you realize that after the first impression of the increasing temperature and some other, for example, deforestation problem and some soil problem and all this data, you will realize that's what is driven forces behind them, and could we really change them? So, and without breaking down of all these type of driven forces, you really feel like you can't do a lot of things. But when you break down the things, for example, hello, you hear me?
Yep.
Yes.
Yeah.
Yes.
But when you break down these forces, then you could start to be more proactive. And in general, my how to say, maybe not request, but maybe what I hear from the scientists, other guys who's working on the climate change last 30, 40 years, 20 years, and spend a lot of the energy and the life to do something. I could say request to managing data correctly. It's a basic for everyone. This is so basic, and it's not solved even close to the 10% of the problem. And I believe InterSystem community, it's so big, and the solution is so impressive, easy to scale, and we have a lot of support from InterSystem team, and we all together could build a really, maybe we could start with the parts, but then because of the interoperability, yeah, because of the interconnection of all these parts, and because InterSystem know how to build this huge system who speak with each other correctly, we could build a very right model of the Earth and resources. And this is even not close to solved solution. And United Nations, if you will explore a bit how they get this data, you will cry. So we think I have this impression. First time when I start to work on the and learn on the climate change, I start to work with the people who is a part of United Nations, who give the resources and data to the United Nations, how they get this data, how they manage this data. I was like, how it's possible in in these years to manage things like this? And it's not because they are not professional. It's because they so dedicatedly work on just in somehow to collect data. They can't manage the things how to manage the data itself. So it's managing data itself is a huge problem itself. So that's why they use the resources what they have to achieve the goals what they could. But if a data transformation and data itself, digitalization of data for the climate change and the resources of the earth will be solved, we will see the real, the fundamental change. Because now in climate change, you need to spend like really hours, months to get from basic insights to the insights what you could drive. And if you didn't also allowed me, I want to show something very emotional. And it will be not the forest and some emotional kids, but I just want to show you this video. As you know, Glasgow was the place where was the last climate change Congress, and Alok Sharma was the CEO of this COP26 report. And in the last moment, India and China, they changed.
May I just say to all delegates, I apologize.
And in the last moment, India and China, they changed the coal agreement. And I want to say, every time when we think about these executives like United Nations, the presidents of countries and World Bank and all others, we think they are like, they know what they're doing and they are so professional, they know how to manage things. But I could say countries can't speak with each other. They have so different point of view for everything. And we see this again and again. And the climate change is one of the most important where we should have the same understanding. And we could have the same understanding on things because the data is overall in general. So it's not about the geopolitician itself. So, and that's how emotional for president who was assigned from United Nations, who spent for so many years to prepare this report. I just want to show you, they are all people and they need help.
May I just say to all delegates, I apologize for the way this process has unfolded, and I'm deeply sorry. I also understand the deep disappointment. But I think, as you have noted, it's also vital that we protect this package.
It's a very emotional, even now for me, even I watch it so many times. And the guys like him and others who work on the climate change, they need help. They can't solve any problems. And any of developer could build a part of the solution, which in general could drive so many changes. And I could say, it's just one of my dream, and this dream came from this contest, by the way. And I want to say again for Muhammad, Yuri, and Sean, a huge thank you, because I realized the power of community and how quickly and just one person could build solution. And I realized if we combine resources and step by step to solve the problems and add and we will work on it, and maybe we will build our own Wikipedia of resources. And this all resources will be in trustful platform where everyone could trust. And InterSystem It's one of the unique company that represented in every country in the world, literally. And many governments and many big states use it. So there are trust. And I think it's really, it's like, it's goosebump now. I feel InterSystem could give a huge impact. And how I could help to this, because I'm not only the guy who just who's worried about things. The guy who's lead the world #6 integrated system dynamics model. So he built the simulation for our resources of the Earth. And Harald Sverdrup is the leading guy in the world. And the world #6 now is one of the most advanced in the world. And it started with, maybe you know, it started in 16th with the reports of first reports, and world #1 platform built it in that days in MIT, actually, where the InterSystem also started the pathway, the way, and it started there. And there are few developers, one of the first developers in the world who start to build the Earth system. And now it's the world #6. And I could say the world #6 is also have a kind of problems, and I could send the materials later if you will need. And it's because of the lack of developers, because of the lack of resources. It's still supported by Rome Club and some of the United Nations most active users and most active representatives. So I think if the guys like who's running the model 6 world of 6 model and others will get this support, and we could build a lot of this type of models, not only the one model #6, but the methods of how to build the models like this, and to in many dimensions to see the data and collect the data, etc. And one.
Einar, I think you freezed. Yeah.
Listen, the webinar, what we did with.
But we lost you there.
Einar, you're breaking, but
this podcast, and then in the third part of the podcast, I asked the questions what to do, and what he will do if he will have all resources with no limits. So his answer was very interesting and inspiring. Also, we discussed about the second topic, Dean, and food could be one of them. And second could be the declaration on the forest and land use. The forest and deforestation itself is a huge problem. It's a #1 problem. In overall, if you know, in the game, you start a very hard mission, you need to save yourself and then go to this mission. And in the climate change, the deforestation, we need to conserve forest. And among all that things what's happened in Glasgow, it was one of the most successful conference ever, starting from the 40 years ago. And that's like 145 countries signed this. It's first time ever in the history so many countries signed this agreement. And 90% of forest is represented. And I think Yuri know that the problem of deforestation in Brazil, and it's not, it couldn't change with just decisions of Brazil. It should be decision of the whole world and support of the whole world. So deforestation could be one of the first problem, one of the first part of big integrated data solution. And again, I have a very huge team scientists who work on the deforestation problem and forest itself. so we could have a huge inputs in the next contest. So I'm done. So thank you, Ken and Evgeny.
Thank you. Thank you,
you.
Einar. Fascinating. Fascinating.
That's
And
true.
again, shows the breadth and depth of the challenge for sure. Did Raj? Did he have to leave? All right.
Raj left.
Yeah. Okay.
the
Well,
meeting, yeah.
let's wrap it up. Thank you all again. Fantastic work. We're very, very glad at how you approached this particular contest. We'll be announcing our next contest soon, and we hope you all participate. Thank you very much.
Thank you.
Bye-bye.
Thank you all.
Bye.
Bye.
Thank you. Have a great weekend.